Okay, today we're going to just expand what we know from what we know already about congruence and about our vivid images. Okay, what do we know so far about congruence? The word congruence. Okay, Contagious.
It's the same size, the same shape.
When we hear congruence, we think about the same size and same shape. Very good. And what about vivid images? Jerry?
Translation.
Okay, we talk about the three basic vivid images, and what are they? You say translation,
Reflection.
a reflection,
Rotation.
and a rotation, right? Okay, very good. So, if we're looking at vivid images, we're looking at, I'm using a triangle that I have on the board. I'm going to move this one to the side. I'm looking at the green triangle I have on the board. I want you to show me a rotation. Okay? Okay? Santonio? Show us the rotation and tell us about the rotation that you use.
I rotate the vivid image to a 90-degree clockwise.
He rotates, did you agree with that?
Yes, ma'am.
Okay, he rotates 90 degrees clockwise. Very good. Okay, what about a reflection? A reflection. Raekwon? Okay, well, reflection, we think of reflection as nothing but a what?
Flip.
Nothing but a flip. And what did you flip it about? Or what did you reflect it about?
Over the y-axis.
Over the y-axis. Very good. Very good. Okay, and one more we leaving out. What's the last one?
Translation.
Translation. Okay, Taquasia. Okay, and tell us about that translation.
I translated it down.
Translated it down. In other words, she did a slide down. Now, you notice through all of these images, vivid images that you perform, did the size of my triangle change?
No.
Did the shape of my triangle change?
No, ma'am.
What changed?
The location.
Nothing but the location or the position. Very good. Okay. So, but today we want to look at our objective for today is we're going to know that we're going to know the definition this time. We talked about congruence as being the same size and same shape, but now we're going to know that the definition of congruence and the related notation of what do we use, what symbol do we use for congruence. We're also going to know that to prove that two figures are congruent, like the two triangles we had, the two figures are congruent, there must be a sequence of rigid motions. A sequence of rigid motion that maps one figure onto the other one. Yes, ma'am?
So it's not on the same size, same shape?
It's still the same size. Okay, listen to her question. Very good question. It is still same size and same shape, but we just get a more precise definition now. Okay, and we'll see how that's going to, how this definition compares to just same size and same shape, how they're going to coincide. Okay? Any more questions? Okay. So what I'm going to do now is we're going to look at this example. I have, again, two triangles on the board. I have triangle A, B, C, and I have triangle A prime, B prime, C prime. Okay? And I'm saying that those two triangles are congruent. Oh, by the way, this is the symbol for congruent. That's the symbol for congruent. When you see that symbol, that means congruent. Okay. I'm telling you that the triangle ABC is congruent to triangle A prime, B prime, C prime. And we're going to use what we learned today to prove that those triangles are congruent by using our rigid motion. Okay? Remember we said in order for two figures to be congruent, what must happen?
It has the same size, same shape.
It must have the same size, same shape, and what else? think about what we just said. What was the objective? We have to map one figure to the other one. Make sure one figure mapped using a sequence of rigid motions. Okay. So this is example 1. Can anyone demonstrate to me how you move from one to the other one? Okay, Giovanna? It's not that one.
A good demonstration would be translate it to the left and rotate.
Okay, so you're saying a translation? Will you come up and demonstrate that for us? Be loud to listen. Okay, so you can actually move that and show us how you're gonna translate it.
Use the A as the center point and rotate it to where it is aligned with the A prime, the B prime, and the C prime.
Okay. So, and he did a rotation. You said rotation. You did a translation, right? So that was that sequence of rigid motion to get it mapped. Now we can see that the one figure is actually congruent to the other. Okay. Any questions so far? Okay. Let's look at your. Before we look at your example 2, what rigid motion would bring those two triangles together? What did you say? A translation and a rotation. Okay. Very good. Any questions? Okay. Or in his case, he said translation and rotation, but I think he only did a translation twice. Oh, no, you did do a rotation. You're right. You did do a rotation. Okay. What rigid motion would bring together one pair of sides? If I was trying to get one side, we talked about the angle. If I was trying to get one side, what rigid motion would we use?
Rotation.
We use a rotation. Okay, you would rotation about one of those points. Okay, so again, what do we mean by congruency now, other than same size and same shape? Mapping one figure to the other one using a sequence of rigid motion. Very good, very good. Okay. Now, let's look at on your sheet, in your book. I'm sorry, your workbook. Let's go ahead and work exercise 1. You can work with your table partner. You can work with them since your table partner is not here today. Work with your table partner. Okay, go ahead and work.
So don't you have to like
Translate it up.
You can translate it upward. And that way it could be reflected. Yeah, it could be reflected.
Point B is going
With that way it could be. I think it could be a vector going across. Yeah.
Point B.
Yeah. Call it point B.
is one.
Reflected. I mean, it's translated. Yeah.
Translate it down.
And on the S2 and S3, have to translate and rotate 90 degrees.
Okay, good job. Okay, so now can I get a volunteer to come to the board and demonstrate to us? I hear the discussion that you are doing, and it sounds good. So now can I get someone to come and demonstrate that to us? Okay, Jovan.
I have a mind.
That's fine, we take right down. Let me get my pen. Okay, use that one, I'm sorry, use that one. Thanks, baby. So, and you can tell us what you're doing as you're doing.
First, I drew a vector from S1 to S2, and I called it point B. Next, I translated it along the vector, and rotated it to point B to a 90-degree angle.
Okay.
Next, to a 90-degree angle clockwise, and next I reflected it along the x-axis. Yeah, I reflected along the x-axis, and that's how I got S3.
Okay, is that what all of y'all did? You maybe your sequence may have been different, but you still use those same three motions, right?
Yes, ma'am.
Okay, so this is what Jovan said. First, he did a he drew a vector and he translated it along the vector. And then he did a rotation, but it looked like he should have did a reflection first, and then we did the rotation. It's because mine is not drawn to scale like yours. Okay, very good. Very good. Any questions?
No, ma'am.
Okay. Now, let's review. What did we learn today? Kintasia?
A new definition for congruency.
A new definition for congruency, because you're stuck on same size and same shape. So what is your new definition of congruency?
It's a sequence of mapping one figure to another.
Okay, it's a sequence of rigid motions mapping one figure to another one. Okay, what about the symbol? What does that symbol look like to you? The symbol we use for congruency. What does it look like to you? Okay, Manjarian?
Either like an equal sign.
Like an equal sign with a little squiggly on top, right? So when you see that now, you'll know that that means congruent. Okay? Now, you all have your exit ticket. Complete your exit ticket. And tomorrow, what we're going to do with those same sequences, we're going to see how we use the process of the sequence of rigid motions to determine whether one angle is congruent to the other one, or whether one side is completely congruent to the other one, or we're going to use two parallel lines cut by transversals. We're going to look at the angles that they'll form. Okay, any questions about the lesson today?
No.
Okay, I'll go ahead and give you about 3 minutes to complete your exit ticket.